Hello everyone, I welcome you all in this course Introduction to Sequence Stratigraphy, and today in this lecture we are going to discuss about another very important systems tract as part of our series of discussions on the different types of systems tract. So, our today's topic is low stand systems tract, which we commonly abbreviate as LST, low stand systems tract. So, in this class we will discuss about the low stand systems tract, and which will be continuing in next lecture as well. So, low stand systems tract, it is commonly is defined as that part of the deposit, that part of the depositional systems which are restricted to all sedimentary deposits which are accumulating during the stage of early phase of rise of the base level. So, that early phase of rise of the base level gives rise to normal regression, and that normal regressive part is identified as the low stand systems tract. So, always in this low stand systems tract, it will form during the early stage of the base level rise. So, always we get this LST, always we get this low stand systems tract immediately after the falling stage. So, at that time when the base level is going through this turnover from the fall to the rise, the rate of rise is commonly less and it is very commonly outpaced by the rate of sedimentation going on in that particular basin. So, that actually results in the normal regression in the sedimentary basin. So, if I just call back that base level curve, so in this fundamental base level curve, we know this is the turnaround point from where this falling phase is changing into the rising phase. So, during this particular phase, the rate of rise is significantly low with respect to rate of sedimentation, and this gives rise to a normal regression during this phase, and this normal regression is commonly identified as a low stand systems tract or LST. So, always in this kind of LST, at the bottom part what we expect, if this is the LST package which is forming during this time frame, during this phase of the base level change, then the underlying surface, it is commonly expected to be the last surface that was present at the end of the force regression. So, it should be either an unconformity when we are looking into the continental side, or maybe in the marginal marine side, or it can be a correlative conformity surface when we are looking into the relatively deeper part of the basin, or maybe in the self edge where deposition is going on, some deposits are forming as part of the falling stage systems tract. So, the lower boundary for this package, for this depositional cycle, is either an unconformity or a correlative conformity surface. As we expect during normal regression, an overall coarsening upward succession. So, always we can expect a coarsening upward succession during the LST phase, and when we reach to this end point of this LST within this base level change, it changes into the next systems tract, and that boundary, commonly this next systems tract is the transgressive systems tract TST, that already we have discussed in our earlier class. So, that turnover or changeover from this coarsening upward succession forming during the LST to the TST package is marked by another very important surface which is called as the maximum regressive surface. So, already we have discussed about the different aspects of maximum regressive surface. So, the LST, which is our topic of discussion today, it will be bounded by either an unconformity or correlative conformity at the base and a maximum regressive surface at the top. So, the depositional processes and the stacking patterns, these are commonly dominated by relatively low rate of aggradation and progradation. Aggradation, its amount, its extent will be less, progradation will be more across the entire sedimentary basin, because during this time the accommodation created by this rising base level will be immediately occupied, will be immediately consumed by the incoming sediments which are coming at higher rate. So, commonly we expect aggradational, low rate of aggradation, and progradational, dominantly progradational sediment package, dominantly progradational stacking pattern of the strata formed during the LST phase. So, accommodation, it is made available by the rising base level. So, what we get over here is gradual increase in the thickness of these low stand wedges or low stand deposits, which appear as a wedge because the accommodation is gradually increasing, and that accommodation gradually overlaps towards the continental side, which is getting deposited or filled up by the incoming sediment by the fluvial system. So, the appearance of that entire package, it looks like a wedge which we call as low stand wedge, as in case of high stand we have seen high stand wedge, high stand prism. Like in this case also we can expect a low stand wedge, which is generally expected to include the entire suite of depositional systems, starting from the fluvial part to the coastal and marginal marine part to the shallow marine self part and up to the deep marine part. So, during low stand, during LST condition, we expect deposition going on through the entire part of the basin, starting from the fluvial part to the coastal area, shallow marine part and in the deep marine part. So, all these areas get affected by the depositional processes of its own characteristics during the LST phase. So, from that point of view, this phase is again a completely distinct, completely different in terms of the conditions which were prevailing during the forced regressive condition or during the HST condition. So, what happens or what are the distribution of these different sedimentation packages or sedimentary packages, deposits across the entire basin, so that we can go through this very basic diagram. Let us think of, this is the subaerial unconformity which is formed in the continental side at the end of the forced regression. Then also we know when we reach to the self edge at the end of the forced regression, then in this part we expect a delta has formed along the slope, and then we come down to the basin floor where we get deposition of the turbidite deposits, high density turbidites or the mud flow deposits. So, this part or maybe in this part, this is the correlative conformity surface. Here also we can get the correlative conformity surface, and in this part this is the unconformity surface. So, this is the substrate which is available at the start of the LST. So, at this point the base level is lying somewhere here at the end of the forced regression. So, from this point onward base level is rising up during the LST. Say for example, base level is rising over here, is coming over here. Now, for this much of base level rise, several processes goes on, several changes in the depositional processes takes place across the basin, and we get different types of deposits in different parts of the basin. So, definitely that area which is not covered under water even during this rising of the base level during LST, that will not get any deposition, that will not face any kind of deposition. But what is expected, as the base level is rising up over here, the fluvial profile which was earlier reaching at this point, this fluvial graded profile, fluvial equilibrium profile will try to rise up. So, as a result of that, that new fluvial equilibrium profile will be somewhere here. So, the fluvial system will face some amount of aggradation. So, fluvial systems will no more incise. At the same time, the sediments are supplied over here in this part. So, at the very first instance, say for example, if the first level of rise was here, this is the first level of rise. So, for that first level of rise, we can expect the fluvial system to deposit the sediments over here, and along with that the delta front will be developed over here. For the next level of rise, the fluvial system will be developed like this, and the delta front or the sediments will be deposited over here in the form of clinoforms. For the third level of rise, we will get the fluvial system coming over here and the clinoform is forming like this. So, effectively the shoreline is gradually moving in this direction. It is like the first level, the second level, the third level, and it is going on like this. So, in this fluvial part, if this was the first extent of the fluvial deposit during the LST, during the start of the LST, the next fluvial deposit will be continuing up to this, because the base level is rising up, it is getting the extra accommodation. The third one will be covering up like this. So, what we are getting over here is the fluvial system is showing an onlap towards the landward direction, whereas as you can see over here the shoreline is moving in this direction, which is indicative of a normal regression. So, this part which is part of this delta formation is the delta plane, and this delta plane is showing aggradational pattern. The delta front, it is showing aggradation plus progradation, dominantly progradation along with that aggradation. So, now here we are getting a prominent delta plane forming again, which is aggrading, and prominent delta front is also developing, which is prograding with little bit of aggradation. So, the dominant deposition is concentrated over here at the self edge, and from the self edge it will prograde in both direction, it will move in both direction. Fluvial system will gradually start onlapping over these unconformity surfaces towards the landward direction, and the delta system will prograde over the earliest surface which is available at the end of the forced regression. Along with these deposits which are occurring along the self area, within the self edge area, we can also get some deposits forming in the deep marine part in the form of low density turbidite deposits. So, again a mass flow deposit, but these are low density turbidites which are again dominated by sand. So, sand dominated low density turbidite deposits will be forming in this part, in the deep basinal part. So, during LST part, this phase of normal regression at the end of the maximum amount of fall and when the base level starts turning around, at that phase we expect deposition going on in terms of fluvial component over here, in terms of deltaic component over here, which is associated with coastal area as well as the self area, and we expect deposition in this deeper part of the basin in the form of again some stacked fan, where the constituent flow is the low density turbidity current which deposits sand again. So, in a nutshell, this is the overall distribution pattern, overall depositional pattern. Along with these portions, also the fluvial system in the upstream area, they will also experience overall aggradation pattern, as the river equilibrium profile will face an overall rise, overall aggradational pattern because of rising base level condition. So, the LST part, the LST deposits which is forming in this kind of scenario, in this kind of condition, so they are having different type of contacts at different areas. So, when we are looking at this area, this part of the basin, this is entirely of unconformity, it is forming above the unconformity. So, the lower bounding surface is the unconformity surface, whereas in this part or in this part the surface, the lower bounding surface is the correlative conformity surface. So, the LST deposit is bounded by subaerial unconformity or its marine correlative conformity at the base, whereas we already know that at the top it is always bounded by the maximum regressive surface, the MRS. Now, there can be situation For example, you can take one case, say the continental shelf was underwater during the onset of base level rise or at the end of the base level fall. So, when the force regression is ending up, the base level fall was not up to that extent that it was reached or it has reached up to the shelf edge, it was confined within the shelf. So, as a result of that, some part of the shelf was still submerged underwater, and when we get this kind of scenario, definitely we expect an erosional surface, commonly a RSME surface forming over there, and that surface may be the youngest part of this kind of surface formed in this kind of scenario will be the bounding surface for the LST at the bottom part. So, this is a special case. This is one kind of scenario which can also occur. So, when we are talking about the lower bounding surface for the LST, we can have this scenario as well. So, what is the scenario? Say if this is the shelf area and during the fall this is the shelf edge. So, what we know, what we have discussed during our discussion on force regression, the late phase of force regression, late FSST, we assume that the base level is reaching over here. But say for example, if it is not coming down to this level, say the base level is reaching somewhere up to this, it is not coming down beyond this. So, this part of the shelf is still underwater during the force regression, and here definitely high energy waves will be acting, and these waves will be creating surfaces, erosional surfaces like this, which we call as RSME surface. And on this RSME surface, what we get? The deposition of the delta X sediments. Now, for the next phase of fall, say for example up to this, we will get another RSME surface formed like this, and on this surface we will get the delta deposit. Say for example, this is the end of the fall, and from here now the base level is rising up. This is the start of the LST now. So, for this portion, this RSME surface is the substrate for the LST on which the LST delta will form over here. So, in this kind of scenario, we are getting unconformity as the basal boundary in some portion of the basin for the LST, in some part RSME surface. So, this is the unconformity surface, this is the RSME surface on which we are getting the LST delta forming, and in some part the correlative conformity surface on which the LST is forming. So, the lower bounding surface can vary from area to area depending on the conditions prevailing in that particular depositional area within the basin. We can have different types of underlying surface, the lower bounding surface for LST, but the top bounding surface is always the maximum regressive surface. So, if I want to discuss little bit more about what are the actual depositional processes and what are the resultant products in terms of distribution of different depositional environments and the different depositional systems during the LST, we can take help of again a very simple diagram. So, commonly the low stand deposits, they typically consist of the coarsest sediment fraction of both the non-marine and the salomarine part, because at that time the succession that is forming, the package that is forming, it is either part of the fining upward profile which is forming in the non-marine part. So, within that fining upward part, this is the basal portion and that will be the coarsest fraction. If you look into the marine part, where we are getting a continuous upward coarsening succession continuing from the underlying regressive sections, regressive units. So, here definitely we will get the coarsest part of this upward coarsening profile in the salomarine part. So, always the LST, these low stand deposits, they typically consist of the coarsest sediment fraction of both non-marine and the shallow marine sections. So, if I consider the continental side, there what we are getting, there will be fluvial onlap, and this fluvial onlap will continue during the transgression, which will be overlying this LST. So, when this onlap is going on, what we expect, if for each and every unit it will be a fining upward succession, it will be gradually a fining upward succession, and overall it will be a fining upward because the system is gradually moving towards the land. So, definitely the LST part, it is carrying the coarsest fraction of this unit, and this is continuing in the transgressive part which is overlying this. So, within an overall fining upward trend, when we are looking into the continental side, overall fining upward trend is observed, and within that the LST part, which is occupying the basal part of this fining upward trend, it represents the coarsest fraction. When we are looking into the deeper part of the basin, we have the HST at the bottom. So, that HST is a coarsening upward trend, followed by the FSST. Again, during FSST it will be a coarsening upward succession, and on that we are getting the LST. So, it is expected to be more coarsening upward. So, overall we are getting a coarsening upward trend during this continuous regressive phase, and as a result of that, in the LST part, in the shallow marine area, we get the coarsest fraction of the deposit, which will be available in the entire deltaic succession which is forming over here or within the fluvial succession. So, in the fluvial succession, the nature of stacking is different, in the marine part nature of stacking is different, but the resultant product is the coarsest fraction of the grains available within the LST package. So, if I now look into the overall depositional processes and products that forms within LST, we can start from the fluvial part. So, in the fluvial part, we know that, say if this is the scenario at the end of the forced regressive phase, at the end of the FSST, where we know that the river system has gone through significant amount of incision, and there will be several tributaries of this river system which is also facing significant amount of incision process. So, during this LST, as the water level is rising, and in response to that water level rise, there will be change in the river equilibrium profile. So, the first thing that will occur over here, that the river incision will stop. So, what we get is unincised river system, unincised river system. But within this river system, if you can understand, say it is starting from here in the source area, and during the forced regression it has reached up to the self or even up to the self edge. So, there is a significant amount of gradient that the river has achieved now, and which is supplying huge amount of sediments. So, those sediments will be deposited within this channel now, and we get completely river channel deposits forming within these unincised channels. So, the river channel will be filled up by water, and there we will get deposits of the coarsest fraction available in that particular river deposit. All the tributaries, they will also get filled up and will get the deposits of the coarsest fraction available in that particular flow. So, what kind of river is expected in this kind of scenario? When you have the coarsest fractions available, they are abundant, we commonly expect formation of braided river systems. So, a braided unincised river system will form at this particular phase in the fluvial part. However, this is not the part of the marine system, this is entirely fluvial system, but this has a connection with the base level. This has a connection with the base level change occurring in the marine part. So, definitely if I continue this into the further marine part, where this river system is further continuing, and there it is forming a delta now, because it is reaching over here, the sea level is somewhere here, maybe somewhere here, and the sediments which are carried by the river are now dumped in this area. Maybe this is initially the self edge or self slope break. So, at this point these sediments will be dumped. So, what is happening now in this part, the river system, it is carrying the sediments and depositing them like this. So, the river profile is going up. So, here gradually we will get layering or the sediment of the fluvial system gradually rising upward due to this rise in the base level through aggradation process. So, what we get in this part, this is the river plain aggradation is going on. Now, this river or this part of the river is actually affected by the marine processes, tidal influences. So, basically they are forming part of the delta plain. So, what we are getting over here, delta plain aggradation. Delta plain aggradation will go on over here. What will be the nature of the river? It will be dominantly braided, unincised braided river system, and it will form part of the delta plain where these channel systems will be supplying the sediments and they will gradually aggrade upward. And the sediments which are carried by this river, they will dumped at the river mouth area, which will form the delta front. So, this delta front, it is getting high amount of sediment supply. So, those sediments will be carried forward and will be reworked by the longshore currents which are going on over here, by the wave activities which are going on over here, and they will form the delta front deposits in the form of successive clinoforms, and that will prograde in this direction. So, as the time will be advancing, we will get systematic change of fluvial aggradation and delta front progradation, delta plain aggradation and delta front progradation. So, in that way we get the self edge delta forming over here at the self edge, and that will grow. So, in this case, what is the difference between this self edge delta with the earlier self edge delta that is forming or that we have discussed in our class on FSST? In that case, the aggradation part, the aggradation of the delta plane, the formation of the delta topset was absent. Now, there will be a very well developed delta topset, a very well developed delta plane, and the fluvial system will gradually onlap, gradually move back from here on. From this point onward, it will try to move back in this direction. So, along the self slope break, we are getting the delta forming over here, the self edge delta, and from there, as these are also reworked by the marine processes which are going on over there, so that will lead to supply of turbidity currents, sediment loads forming turbidity currents, and that will come down the slope, reach the basin floor, and when they will be reaching the basin floor, there they will spread out, forming the again splay like structure. So, this kind of deposits forming low density turbidite or low density turbidity currents, they will carry sand. Since they are low density, their fluidity will be high. So, they will be carried further and they will be depositing somewhere within the outer part of the submarine fan toward the distal part of the submarine fan, and they will form low density turbidite deposits. So, in terms of overall depositional processes and products of the low stand system strat, we can expect 4 major events occurring over here. Number 1, fluvial aggradation is occurring, resulting in unincised braid plains. Second one, delta plain aggradation is occurring. Third one, delta front progradation is occurring, and these two are occurring at the self edge. So, we are getting a very well developed self edge delta. And the fourth one, low density turbidites are forming in the deep basinal part on the basin floor, and they are forming part of the submarine fan. So, these are the major depositional event and the corresponding products that we can expect during LST in overall depositional basin, starting from the fluvial part to the deep basinal part. So, if I look into this low density turbidite, we can start our discussion little bit detailed discussions on each of these aspects. and there we can start with these low density turbidites which are forming in the deep basinal part. So, when this entire process is going on during the LST, the coarser sediments, they are getting trapped towards the shallower part, towards the coastal part of the basin, because the water level is rising now. So, the coastal area or the shallow marine part, it is becoming the high energy zone where sediments are getting distributed and they are getting locked up over there. So, from the shelf edge onward, or maybe even within the shelf area, the supply of the coarser fractions, they are little bit scarce as their supply is restricted now. So, when we have this trapping of the coarser fractions towards the shallower part, so at the onset of base level rise, this reduces not only the net amount of sand which is supplied to the deep water environment, but also changes the sand mud ratio, also increases the sand mud ratio of the sediment load transported by the turbidity currents. So, what is happening now? With respect to the earlier turbidity currents that we have seen during the late phase of forced regression, where we have seen huge amount of sand is supplied, the sand mud ratio is extremely high, in fact the proportion of mud is almost negligible over there at that time. So, we got high density turbidites which is dominated by sand. In this case, during the LST phase also the mud supply is very low, but also the sand supply is also very low. So, the overall sediment load in the flow is significantly less, which results in low density of the turbidity currents. So, the low stand sediments of this basin floor submarine fan complex, they are overall finer grained with respect to the underlying late phase forced regressive deposits, for example, the late phase high density turbidite deposits, because the overall supply of the coarser sands which were available at the time of late phase of forced regression are now absent. They are restricted more towards the coastal area as the sea level is rising. So, when the sand supply is less, when the overall sediment supply is less within the flow, so definitely the density of the flow will be less, fluidity of the flow will be more. So, the maximum grain size of the sediment which is transported by this kind of gravity flows during the LST is also expected to decrease with time, because as the base level is rising during the LST phase, it is resulting in the onlapping of the fluvial system, the trapping of the more sediments into the delta plain area or maybe within the delta front area. So, as a result, as the base level is gradually rising up during the LST phase, what we are getting is gradual lowering in the supply of coarser fractions towards the deep marine part. As the base level is rising up, the fluvial slope, the fluvial gradient, this is also gradually rising up, it is also adjusting itself, and that adjustment of the fluvial profile is resulting in less energy of the fluvial system, and when you have less energy, the chances of supplying the coarser sediments is less. So, overall, as we are going towards the late phase of the LST, or gradually as we are going upward within the LST, the supply of the coarser fractions or sediments will be more restricted towards the fluvial part, and they will not be transported towards the deep basinal part. So, due to this lower sediment water ratio, the low density turbidity currents are forming in the slope area, which tend to be underloaded in terms of sediment load. They remain underloaded on the continental slope. So, when they are underloaded, but there is a sediment gravity flow, so we expect higher energy, higher flow velocity, more fluidity, and then this kind of flow will move down the slope through channel entrenchment process. So, there will be not much of aggradation, but more of entrenchment of the channel through the earlier deposited sediments. So, along the slope area where the gradient is high, the slope is high, this kind of flow will try to entrench through the earlier sediments and they will come down to the basin floor. Now, as soon as they have reached the toe region of the continental slope, as soon as they are reaching the basin floor, where the slope is significantly less and there is a sudden break or sudden change in the slope or gradient, these low stand turbidity currents will lose their energy, will lose their velocity, and they become overloaded with respect to their sediment load, and due to that this basin floor setting will record aggradation of the Leavitt channels. So, during the low stand normal regression, we expect aggradation of Leavitt channels in successive phases forming in the deep basinal part, particularly in the basin floor area. So, what we get over here, successive Leavitt channels are forming, they are cutting through the earlier high density turbidity current deposits and they are forming splay like structure. Those splay like structures will be spreaded one after another, they will stack one after another forming the submarine fan complex. So, we will continue our discussion on the other aspects of the LST. So, in this particular lecture, we have tried to look into the overall character or nature of the LST deposit and what are the broad area of distribution of sediments, what are the broad depositional processes that commonly we expect during the LST phase that we have discussed. So, it is mostly confined in the fluvial part where we get fluvial aggradation. We can expect that in the formation of a well formed delta starting from the self edge, and there we get delta plane for that self edge delta. We can expect the delta plane to aggrade and it forms a wedge like structure which we call as the low stand wedge. The delta front part that shows a huge amount of progression with little bit of aggradation, and we can also get some deep marine turbidites which are commonly low density turbidites, as the supply of coarser fractions are significantly restricted now as they are getting trapped, they are getting restricted in the marginal marine part. So, as a result we get Leavitt channels, entrenched channels which get superimposed, which get stacked one after another, and they form splay like structures at the marginal part of the submarine fan complexes, producing relatively low density turbidite deposits within the submarine fans. So, these are some of the references that you can follow for further study on this particular area. We will continue this discussion on other aspects of LST in our next lecture. So, thank you everybody.